All right, guys, in this video, I'm going to go over how to do the car project and the college fund project that is due tomorrow. So for the car project aspect of it, what you need to do is you need to pretend that you are going to buy a new car. So you can select any car that you want. Really, it doesn't even have to be a new car per se. You can select any sort of car, but you do have to get the value of it and find a picture of it. So let's just go into, we can go to a quick website, edmunds.com. So on edmunds.com, I can search for the type of car that I want to buy. So let's just say I want to buy a convertible. Oh, I don't know. In this price range, I want a BMW. All right, so I want to buy this BMW 1 Series convertible. Starts at $36,900. So here you buy a new car for, I would put in this case $36,900. You can do whatever sort of vehicle that you want. The value Y of the car decreases by 16% each year. So this value of my car, $36,900 on my BMW 1 Series convertible, is going to decrease 16% every year. So instructions say that you will need a picture of a car and its price. So in this case, I would just print up this page or this picture and this price. Write an exponential decay model for the value of the car. Use the model to estimate the value of the car for the next 10 years. Let me zoom into this. This can be the exponential decay that you can use. This could be the model, except in your case, what you would not fill in is the t, but you would fill in everything else. So y, the value of the car. Remember, it shows the value y of the car, so that's y, the value of the car. A is the amount, so my A would be $36,900. 1 minus R. Remember, R is the rate at which it decreases. In this case, it's 16%. So I would put 1 minus 16% when you do calculations is 0.16. So you need to convert that 16% to 0.16. And then I would just leave it as a t because I'm doing just the decay model. I don't want to actually start plugging in any values for t yet because that's what we are going to use. So now it says use the model, here it is, to estimate the value of the car for the next 10 years. Then we have to graph the exponential decay function. We can use this website to create a graph. This website will help us. So then after we're done with that, we create a poster. It must have a picture of the car, a graph, and the attached worksheet. Okay. So what you would do, this is the website that we provided for you. We don't want a bar or an area or a pie or an X and Y chart. We want a line graph. Okay. Don't really need to change much of this. So I go to data. All right. So what is this titled? Mine is going to be titled. Let me adjust my microphone here. All right. Mine is going to be titled value of, or I don't know, decay of BMW 1 convertible. My x-axis is the one that goes left to right. X-axis is the independent variable. In this case, it is the years. Y-axis is the value. So as years change, what's the value of the car? Okay, data set. How many items do we want? Well, remember it says we want it for the next 10 years. So I want 10. Okay. Item label. So after year 1, what's the value of the car? So this is where you are going to actually have to start plugging in some values into this formula with your numbers. So I'm going to give you just a couple so you can see how you do it, but you would then replace your car value for your information. So let's go into a calculator. Okay, so mine was 36,900 multiplied by 1 minus 0.16 raised to Now, on my Google calculator, which is the one that I'm using, whenever you want to do an exponent, you give it this arrow raised to the first power. Now, the reason why I'm doing the first power in this case is because I'm doing the first year. My value then becomes 30,996. 30,996. Okay? Now, my second year, year 2. It is the same calculation, except this becomes second year, so this becomes 2, where the t would be, this is time, we're doing it to this case. That becomes $26,036.64. So let's go back to my graph. $26,064, oops, excuse me, $36.64. I'll do one more, year 3. Same process, except now it's going to be the third year. 21,870 and 78 cents. 21,870.78. Okay. Labels, we don't really want to mess with that anymore. Preview. So this is what's happening so far with my graph. So this is a decay of a BMW convertible. It started at year 0 at my actually, let's do this. Let's give it 11 items because we have to start at year 0. And we have to move all these values down 1. All right, so this is 21,870.77, 26,036.60. 3996, and then my original value was 36,900. Yes. We preview that. There we go. So I had to make that adjustment because we started at year 0. We always have to have our starting point. So we went from year 0, it was at 36,900. Then after 1 year of this 16% decay, it went here. After 2 years, it went here. 3 years, it went here. And we have to see how the decay keeps going and see what my endpoint is. So that would be basically your processes for the car project. Now, college fund. You and your parents have decided to start a college fund. You and your parents decide to deposit blank amount. You can tell me you want to deposit $10, $100. Now, try to take this a little bit seriously. If you are going to start a college fund, you really don't want to start it with $10 and that's it. So give it a reasonable amount, $1,000, $1,500. Give me a wacky number if you want, 12,472. It doesn't matter. It's up to you. In an account that pays 9% interest compounded n times per year, what will the account balance be after 1 year, 2 year, 3 year, 4 years, up to 10 years if the interest is compounded quarterly, monthly, yearly, and daily? Graph your findings. Consider initial principal P deposited in an account that pays interest and an annual rate R, expressed as a decimal, compounded n times per year. The amount A in the account after T years can be modeled by the following equation. So that is a lot of jargon. Focus more so on this equation here. So the value is the principal that you deposited multiplied by 1 plus, because this is growth now, so we have plus, the rate divided by n, how many times per year it's being compounded, multiplied by, you can't really see on this screen, so let's zoom in, multiplied by n multiplied by t, excuse me, raised to n multiplied by t. So if we want to go back to our graph here, so now this is college fund growth. Okay, I still want 11 items because we're still going to find for 10 years. So in year 0, I want to deposit $12,000. Okay, in year 1, how much would I have at a 9% growth rate? 9%. Now, for this, you're being asked what's going to happen when the account is compounded quarterly, monthly, yearly, and daily. You have to do one graph for one. So first, let's do quarterly. Let's go back to our calculator. So this is 12,000 multiplied by 1 plus the rate of 9%. Oops. divided by how many times per year this is being compounded. Since this is quarterly, we're being compounded 4 times per year. And all of this is raised to 4 times 1. Let's go back. Y, so that's my amount, is P, which is the principal, in my case, $12,000, multiplied by 1 plus R over N, 1 plus the rate, 9%, divided by 4, because we're compounded quarterly, raised to the N times T. N, 4 times per year. T is 1 year. Do the search, so it's 13, 11, 6. So this becomes 13, 11, 6. Okay. After year 2, what happens? Well, the only thing that we change is that this becomes 2 instead of 1. 14,337. 14,337. After year 3, what happens? There we go. 15,672. Okay, so let's preview. Okay, so now we're starting at $12,000, and this is the growth that we're experiencing. We want to see what happens, where does it end up at our 9% growth rate after 10 years, if it's being compounded, in this case, quarterly. Okay, so on my data, I should probably put quarterly college fund growth. That way I'm more explicit that this graph is for quarterly growth only. Now, when you want to change this and do it for, let's say, monthly, you go back to your calculator. Now, instead of being compounded 4 times per year, since this is monthly, this is 12. There are 12 months in a year, so it's being compounded 12 months per year. Okay. So again, we're going to start off with 1 year. So that's 13,125. So now we put that 13,125. If we want to do 2 years, 14,356. 14,356. And then for the 3rd year, see, all I'm doing is changing the T value. 15,703. Okay, preview that. So here it is, it's growing. So right now we can't really do too much of a comparison because I don't have both graphs completed or side by side. So when you're doing this, print up the graph or do it manually. What you're going to have is 4 different graphs, and you can see what happens when you change from being compounded quarterly, daily, monthly, and annually. So for the rest of the project, so we already compounded quarterly, which was 4. Compounded monthly, which was 12. Yearly, well, there's 1 year in a year, so this is the N is 1. Daily, well, how many days are there in a year? Average year is 365. Okay, so this N would be 365. And that is it. So print up those 4 graphs. Print up work. What I mean by work is not just this and not just this. What I want you to do is actually do maybe an Excel spreadsheet. You can do it by hand. Give me this work that I plugged into Google, but show me that you understand how to do it. So on a separate sheet of paper, you can write in 4 different sections the compound growth at 9%. Quarterly for year 1, then you would plug in this formula. This formula. Plug in all the values. Quarterly for year 2, plug in all the values, give me the answer. Quarterly for year 3, plug in all the values, give me the answer. Show me the progression, show me that you know all the steps. That's it, guys. This is due tomorrow. Good luck.